Welcome to Wednesday. Today we will be talking about Newton's third law of motion. What is Newton's third law of motion? Every action has an equal and opposite reaction. That's the law. So when one object exerts a force on a second object, the second one exerts a force on the first that is equal in size and opposite in direction. So when you jump on a trampoline, the trampoline exerts the same force on you, but pushes you in the opposite direction. And the law of conservation of momentum. So first of all, what is momentum? Momentum is just mass in motion. And it's symbolized by a P. So the formula is P equals mv, or momentum equals mass times velocity. So mass kilograms and velocities in meters per second. Any moving object has momentum. And it was transferred between objects in a collision. So this guy in the white football suit costume thing has momentum, and when he tackles the other guy, he's transferring it to the other guy. So that's all it is, it's transferred. Here's our example. So what is the momentum of a car with a mass of 1,300 kilograms traveling at a speed of 28 meters per second? So what do we know? We don't know the momentum. That's what we want to know. We know the mass of the car is 1,300 kilograms, and we know the velocity is 28 meters per second. Here's our formula. Momentum equals mass times velocity. So let's just plug it in. So momentum equals 1,300 kilograms times 28 meters per second. So momentum is 36,400 kilogram meters per second. That's how you say that. That's the unit. Kilogram meters per second, or kilogram times meters per second. In a collision, think of it like this. Because the forces acting on the two objects are equal and opposite, the transfer of the momentum must be the same. So, for example, the red car rear ends the yellow car. The momentum of the red car is actually going to be transferred to the yellow car. So the yellow car, even if it's parked, is going to move forward, right? Momentum is never created or destroyed in a collision. It is only transferred. All right, so here's our law of conservation of momentum problem. Ball number 1 is rolling 11 meters per second directly towards a 0.17 kilogram ball number 2 at rest. During the collision, ball number 1 stops, and ball number 2 is launched forward at 9 meters per second. What is the mass of ball 1? So let's just write down what we know first, okay? We have ball 1, there's ball 2, but we don't know the mass of the first ball. And we know the velocity of the first ball. It's going 11 meters per second. And the second ball, the mass is 0.17 kilograms. And we know the velocity is 9 meters per second. So we want to know the momentum of the first ball, right? We want to know the mass of the first ball. We know the velocity of the first ball, so we can fill that in. We don't know the momentum of the second ball, but we do know the mass of the second ball and the velocity of the second ball. So solving this bottom equation is going to be totally doable. All right, so what do we know about the law of conservation of momentum? If momentum equals mass times velocity, then the momentum of ball 1 is equal to the momentum of ball 2. So if we can figure out the momentum of ball 2, we will know the momentum of ball 1. So the momentum of 2 is 0.17 times 9, right? Or 1.53 kilogram meters per second. And the momentum, so now we're going to take our formula and we need to solve for mass, right? Because that's what they're asking us, mass. So mass equals momentum over velocity. So let's plug that in. We don't know the mass. Do we know the momentum of ball number 1? We do. It's the same as P2. So P1 is 1.53, and the V V1 is 11, so 1.53 divided by 11 is 0.14 kilograms. So the mass of ball number 1 is 0.14 kilograms, which makes sense. It's going at a faster velocity than the heavier one. Okay, so that's it for our PowerPoint today. You do have a sheet to do, and it does actually have 2 sides to it, so take your time. The practice is the motion laws application, so it's actually going to be kind of a review of all 3 Newton's laws of motion. And then on the very back, page 32, is momentum math, and that's going to be specifically around this Newton's third law.